Okay, something else we need to talk about when we're looking at files is the idea of links. Now, you're probably already familiar with links a little bit. So if you've worked in a GUI environment, you're familiar with the idea of a shortcut, right? You put an icon somewhere, you double click that, it runs an application somewhere else, it opens up a folder somewhere else. It is a shortcut to that location. Now, a link is basically a shortcut for the command line OS. We already have some created. So if I do an ls-l in the right window, ls-l, there we go. For the root file system, oops, there we go. You'll see that we have some links created, and you're going to see them here. They have an L, and these are soft or symbolic links. And then you'll see the name and sign, in this case, Ben, and you'll see the redirect to user Ben. So basically, this says that Ben is a shortcut or a symbolic link to the user Ben folder. So that's what a symbolic link is going to look like. We've actually got a couple of different types of links. So let's start playing with them here. And I'm going to do this all in one folder, which normally wouldn't make a lot of sense, to be perfectly honest with you. But we're going to do it anyway because it's going to simplify a couple of things as we try to look at it. So I have this file here named sample1.txt. If I cat sample1.txt, you can see it just says this is a sample text file. Okay, now I want to create a link. There are two different types of links. There are hard links and symbolic links. And we're going to start symbolic, also called symlink, also called soft link. So I'm going to start by creating a hard link. So the command is going to be ln, and I'm going to link sample1.txt to sample2.txt. And now if I do an LSL, you'll see I've got two files. Now I want to make some changes to these just so you can see how this works. Before I do, let me cat sample2.txt, and you'll see that, hey, that's actually the same file. So I'm going to nano sample1.txt, and in sample1.txt, I'm going to add this is a change made to sample1.txt. And you'll notice up here in my title bar, it says that I'm in sample1.txt. Control O to write out. Notice down here, write to sample1.txt. Perfect. Control X. Clear screen. Let me cat sample1.txt. Okay, and there's my change. But if I do an LSL, notice that it is now 67 bytes, but so is sample2.txt. Let me cat sample2.txt. Hey, what do you know? It has a change made to sample1. Does it work the other way around? Sure. Let's go to nano sample2.txt. And you'll see right here, sample2.txt. So I'm going to make a change. This is a change made to sample2.txt. And then write out, whoops, Control O and Control X. Clear, ls-l, sample1 and sample2 both now have 105. Okay, let me cat sample1.txt. And you'll see I have the changes made. So these two files are now linked. Notice, by the way, that this sample2 does not say it's a link. It only displays it's a link if it's a soft or symbolic link. We're going to come to that, back to that in a minute. So now let me create a symbolic link. So my command is the same, ln, but now I'm going to do -s to specify that this is a symbolic link. I want to link sample1.txt to sample3.txt. And let's do an ls-l. Now, this shows up as a link. It has the L. It also has that little redirect thing. Notice that it says this link is 11 bytes. It's not the 105 that sample1 and sample2 are. It's another difference between hard links and symbolic links. We're going to come back to that. So, let's see if it works. I'm going to cat sample3.txt. And hey, there is the entire file. So let me edit it. I'm going to nano sample3.txt. I'm going to add, this is a change made to sample3.txt. 3.text. And then write out and exit, clear the screen. And now sample 1 and sample 2 are both 144 bytes. Let me cat sample1.text. And I see everything there. Let me cat sample2.text. Everything's there. Let me cat sample3.text. And everything's there. Okay. So I have created links and all of my links are working. Sample 2 is updated because it's linked to sample 1. When I edit sample 3, which is also linked to sample 1, it saves it as sample 1, which is then linked to sample 2. And anyway, you get the idea. All right. Now, why the two different types of links? Is there a difference? How do they function? Yes, there is. And in order to understand that, we need to understand the concept of inodes. So I'm going to do an LSLI. And I says show the inode number. And here you're going to see the inode number in this first column. Notice that sample1.text and sample2.text have the same inode number. Sample3.text has a different one. Okay, let's talk about what an inode is. An inode is a unique identifier for the file. If you think about it in terms of a database. So here at YVC, all students have a student identifier number, an SID number. And that uniquely identifies you in our database. And we can use that number to look up your records and see, everything that's tied to you. But every student has a unique one, and that identifies that particular student. Now, in the Linux file system, we've got something similar. We have an inode number that uniquely identifies every single file. So it holds all the metadata for the file. So every file has its own inode number. Now, what a hard link does is it kind of breaks that rule. A hard link creates another name with the same inode number. It's another name referencing the exact same data. So there's some strengths and weaknesses to this. We're going to start with the weaknesses. I can't put a hard link on a different file system from the file that I'm linking to. So think network server or something like that. I can't create a hard link to a file that exists on a network server or remote system because each file system has their own set of inode numbers, and I can't link the same inode number because they don't mean the same thing in the two separate file systems. So I can't create a hard link for that. I can create a symbolic link for that because the symbolic link, you'll see it right here, has its own inode number. So I can create a symbolic link to a file that's on another system and it'll be just fine. Another thing is folders. Let me create a folder here. mkdir folder. I'm going to create a link to folder and I'm going to name it folder 2. And it's going to tell me you can't do that. Hard links are not allowed for directories. So with my hard link, I can't create a link to something on a remote system. I can't create a link to a folder. Symbolic links will let me do both of those. So if I ln-s from folder to folder 2, from folder to folder 2, there we go. Now you're going to see that I have a symbolic link right here. I've got a directory folder and I've got a symbolic link that goes to that folder. cd folder 2, and there I am. Okay, so symbolic links will let me do some things that other ones can't. Now, that hard links can't. So is there ever a reason to use a hard link rather than a symbolic link? Well, there actually is one big difference. So sample1.text, I've got a hard link to sample 2 and a symbolic link or a soft link to sample 3. If I delete sample1.text, it'll delete just fine. Let me clear the screen here to move this back up. Now you're going to see that my symbolic link is broken. So if I cat sample3.text, it says it can't do it. No such file or directory. Even though I'm sitting here looking at it, it doesn't work. However, if I cat sample2.txt, it will work just fine. So a hard link will survive if the source file, the file that you're linking to, gets deleted or moved. A symbolic link won't. And that's the big advantage of a hard link. So what are you going to use? Yeah, depends. Sometimes you'll use a hard link. Sometimes you'll use a symbolic link. My personal preference is I use a symbolic link when I can, which is going to be most of the time. The big advantage that the hard link gives me is if my source file gets deleted or moved, my hard link still works. My symbolic link doesn't. So hopefully that makes sense and gives you an idea of how we can use links. Now, remember, I did all of this in one folder, and normally you would not do that. That doesn't make a whole lot of sense. The reason I did in this case was so that when we did the LS, we could see all of the files in one spot and we didn't have to jump around a whole lot. Just made it easier to see. Normally you would link to things in a different location. Okay, so hopefully that gives you an idea of what links are, how you can create them, and how you can use them in your system.